Brought to you by Chemistry.
Hello everyone and welcome to Brought to you by Chemistry. What's brought to you by Chemistry, I might hear you ask? Complicated reactions, complicated exams, even more complicated romances. Yes, but also in this case, it is a new podcast series from the Royal Society of Chemistry. So you see the branding there. It's very, very simple. Now, last episode for long-time listeners, we spoke a little bit about recycling and how complex plastic recycling can be. Now, that's talking about making it recyclable, reusable, or making products that can be repaired easily. Anything to stop plastic ending up in the oceans or in the ground. We previously talked about the fact that there are challenges there. Some materials, such as composites, can't really be recycled at all. So how do you make the perfect plastic, at least in terms of being recycled? I, of course, have no idea. And if you have an idea, dear listener, I can't tell. The way this works, time travel isn't involved with audio, but I've got a couple of people who might understand what comes into play. Today, we have with us two fantastic experts. So my chemistry expert, could you please introduce yourself?
Hi there, my name is Dr. Jenni Garden. I grew up in Aberdeen, studied my undergraduate and PhD in Glasgow at the University of Strathclyde, and then moved down to work at Imperial College London for a few years before coming up to Edinburgh, where I currently lead a small team of researchers working on sustainable plastics.
Wonderful. And my non-chemistry expert, could you please introduce yourself?
Hi, I'm Mark Pawsey and I'm the Member of Parliament for Rugby, and I was elected to Parliament in 2010. Came to Parliament rather late, having had a business career in the supply of food service packaging products, which is plastic, paper, board, containers. And so my experience with plastics comes to it from working with customers who want to use the materials and making sure we've got what they need. When I arrived in Parliament, I discovered there are, I think, 600 all-party parliamentary groups. One of those is one for the packaging manufacturing industry, and I'm chairman of the all-party parliamentary group for packaging manufacturing.
Wonderful. So you came in late, but you've shot up.
Kind of you to say so.
So let's start with you, Mark. So like you said, you got 25 years of experience in packaging. Now, with that, our recent citizen survey said that 39% of UK citizens agreed with the statement that I only try to buy products in recyclable packaging. So in your experience, what can we do to make it easier for people to recycle plastics? Should we be ensuring that all packaging is recyclable in the first place?
Well, let us start with what people think now, because what people think now is very different from when I started my career in the plastic packaging sector back in something like 1980. And in the early years of me selling plastics, we didn't really have much regard for what happened to the product once it had been used. Our job was to get the customer to use it. In many cases, actually, as we were selling a plastic disposable product as an alternative to a reusable product. So this would be something that, maybe the customer was using a reusable bowl. That meant it had to be washed up. Obviously, in the early days, that was probably using labour, increasingly then using machinery, but at a cost of water and chemicals. And I think attitudes have changed enormously in 20 years, and I do get that people now do want to know that the product that they're using is capable of being recycled. And I think one of the things we do need to talk about is the difference in meaning between something that's recycled and recyclable, because I think for many of the general public the term is used intermittently, and a recyclable product is one that could technically be recycled and but in many cases isn't, and a recycled product is one that is made out of products that has been previously in use. And the key to that is about a bit of education, making sure that people understand the terms, but also the issue of on-label, on packaging labelling that describes exactly the origins of the material, and very significantly what the consumer should do with the packaging once they've finished with it. And in many cases, we have packaging with a lid, and the container should be dealt with separately. But it is all about communication, and we were working towards a set of symbols run by an organisation called OPRL, and there needs to be broader consistency, and everybody should adopt the OPRL packaging, in my view, because everybody would then be able to put some marketing behind it. The other bit I must mention is a consultation the government are doing at the moment about consistency of household collections, because one of the problems we've got is that we can't put on the packaging what people should do with it once they've finished with it, because different local authorities treat their packaging differently. And if we can get to a consistency of a collection, we can then start printing that information on, and we can start increasing the proportion of plastic that is available for recycling.
So Jenni, first question to you, what actually makes a plastic recyclable?
Well, actually, plastics really inherently are all recyclable. I mean, the definition of a plastic or a thermoplastic is a material that can be heated up and it can be reshaped when it's at that higher temperature and then cooled down into a certain form. And so actually, if it was just that plastic or the polymer, then every plastic really should be recyclable. But of course, it's not that simple. And part of the reason for that is actually when we're dealing with recycling streams, then actually it's often not just one type of plastic, but there might be multiple different types of plastics in there that can be really quite difficult to sort and separate. And also with materials, these tend to have been designed for particular purposes. So often it's not just that one polymer that's in the plastic, but actually it could be a polymer combined maybe with a different polymer. It could be combined with colorants or additives. So it's really the complexity of these different streams that make it much more challenging to recycle these materials.
That's actually really interesting because it touches on something that Mark said. I think my question to you, Jenni, and then I think the same thing with you, Mark, is how does product design itself affect recyclability? I mean, Jenni, with your work, can you give any examples? Because I'm thinking things like, pizza boxes, like the films over the top, like those must affect recycling. And those are the things I think when I think of plastics.
Yeah, and a lot of the time it is, there might be a lot of complexity in these systems. So for example, if we think about a milk bottle, these are one of the most highly recycled kinds of materials in terms of plastics. But actually within that milk bottle, I think Mark touched upon this, that there can be multiple different kinds of plastics. So we might have a polyethylene milk container, but then a polypropylene lid and a label that's typically polypropylene. There will be a piece of foil that often has plastic attached to it, and then an adhesive that kind of sticks the label onto the bottle. So all of these different things can introduce these different levels of complexity into trying to recycle one of those materials.
Alex, I think it's important that the product performs. It does what is being asked of it. So it's the ability to be moved from the point of production into a distribution area. So if it's a food container, goes from the food factory to the retailer, then back home in one piece. And I mean, and Jenni talks about a highly recycled item, which is the plastic milk bottle, and in many cases that you need to go back to what was used before. So the plastic bottle took over from the glass bottle, and the plastic bottle needed to do the job. And one of the issues is how do we improve recycling? How do we make material more efficient? That one of the pressures on manufacturers is to reduce the amount of material in the product, and there's a commercial imperative for that, because more product equals more cost. So if we can move the milk in a thinner bottle, so much the better. But if it fails to perform and it breaks or the milk spills over everywhere, we haven't achieved our objective. So I think in every instance we've got to have regard for what we're asking this material, this material to do, what we're asking the product to do, and what's the best material to perform it, and then have some regard for what we didn't think about 20 or 30 years ago, which is how are we going to recover it and how are we going to give it another life. So I would say that in the early stages of my career still in these materials, probably most of it ended up in landfill. Because that was what we did with our rubbish, or we perhaps burnt it in an incinerator. Now the challenge is to get a greater proportion of our material recycled, and one of the ways that we increase recycling rates is by separating out the materials. Jenni draws attention to one issue with plastics, which is that plastic isn't plastic. There are a whole variety of plastics, and they need to be grouped together in order for them to be recycled effectively.
That's really interesting here, because Mark, you're looking at it from the perspective of sort of outside the world of science. Once it has been made, you're seeing how it interacts with the world. You're seeing how we are using it and what that means. But Jenni, from the start, I mean, how does a chemist design a plastic with recyclability in mind?
Well, I think part of the problem is that maybe for a long time it hasn't been. It's been, as we've mentioned, designed for purpose rather than end of life. And I think it really is important to link things up from the materials design, but then also communicating that across how these materials are made into different products and then where they're designed to end up at their end of life. But I think from a chemistry perspective, it's really interesting because there are so many different aspects of recycling. I think so far we've spoken about mechanical recycling, which is what we kind of conventionally think about with recycling, heating up and reshaping different plastics once they've been separated out. And in terms of this, then chemistry has a huge role to play. So one of the issues with current recycling processes is that often the materials become reduced in terms of their quality upon each round of recycling. And this can be due to different plastics being present as contaminants, or it can be due to things like the length of these polymer chains being reduced. And so that changes the molecular structure and it changes the properties of that plastic material. But there are chemistry approaches to being able to extend those chains back up to being longer again. So chemistry certainly has a role to play within lots of areas of mechanical recycling. In terms of other types of recycling, then there's also something called chemical recycling. So with mechanical recycling, because we do tend to reduce the properties upon each recycling, then chemical recycling is kind of complementary to that in a way, because it actually completely breaks down that polymer chain. And then you can either, depending on what it's broken down into, you might be able to rebuild that up. So sort of reversibly make and break that polymer structure. Or you can break it down into small molecules that actually might be useful for really quite different purposes. Things that could be useful chemical feedstocks, and chemicals that could then maybe be made from plastics instead of from fossil fuels, or be used in different applications. And then, of course, there's biodegradables, which I think will be a feature of other podcasts in this series. And so there's a really interesting combination of different things here. And sometimes the chemistry that underpins these different approaches can be quite different. It's not necessarily a one-size-fits-all approach.
Jenni's explaining, as I understand it, is why manufacturers generally would prefer to work with wholly virgin material, because you know entirely what you're getting. It's come from one feedstock. Whereas with recycled material, there's the danger of even slight contamination affects the usability of the material. And the government is providing an incentive for plastics manufacturers now by putting a tax on materials that don't contain 30% recycled. So, I think the point Jenni's making is that you can't constantly recycle. There is always going to be a need for some virgin feedstock to maintain the integrity of the product, if I've understood you correctly.
So it depends on how pure the batch of the polymer really is. And in reality, most of these different polymers have different contaminants or different colorants, different additives, which does make it difficult to recycle back to the same quality as the virgin feedstock at the moment. But there's a lot happening in recycling technologies and a lot of really exciting research coming through. So hopefully things will improve and keep on improving. And
I suspect the nature of the material, again, going back to the point I originally made, goes back to the application. So if it's a component in a car that's going to last the life of the car, you would want something that's of very high quality. But if it is a single-use container, you might be able to compromise more than the other products. Well,
it's a really interesting point to bring up, actually, because although we think of disposable packaging and often food packaging as being quite a disposable and not very valuable feedstock, then actually there's quite a difficulty with recycling materials to a food grade standard. So if we have food grade packaging, that has to be a certain standard, and then that has to be, if you're using recycled materials for food grade applications, that has to always be of that standard. And so tracking where that material goes throughout the system can actually be quite difficult. If we had something that was to be part of a car that couldn't necessarily then be converted converted or recycled into something that was food grade packaging, even though we might think of that as being something that's quite disposable, whereas the part of the car might be something that we would think of as being more high tech. And so there's really an intrigue in how can we keep those food grade quality materials in circulation. And so things like bring back schemes, or maybe even there's some ideas about looking into molecular tagging, and can we almost put chemical barcodes onto these different polymers to track where they end up, to know that these food grade quality packagings are being maintained in circulation.
See, that's really interesting. What both of you said, because Mark, you talk about having that virgin feedstock, bringing in new feedstock in order to keep this recycling going. Now, Jenni, I know you've been doing work into designing more sustainable plastics as alternatives to today's plastics. What's your work looking at, and could we get to a world where Mark no longer has to think about virgin feedstocks, in that we could just solely have sustainable, fully recyclable plastics?
I would love it if we can get to that point. That would be fantastic. And I think, from a chemistry perspective, there would be such an intrigue in having a material that could be mechanically recycled. If it gets to a point that it can't be recycled into the same quality, can it then be chemically recycled and broken down and then rebuilt up into something that is equivalent quality as virgin plastic? And ideally also, if we're being really, really cheeky, is kind of hoping that something that if it was to be leached to the wrong environment, to the natural environment or to the ocean, that it would degrade into something that is non-toxic and benign. Now, this is a pretty challenging combination of things to do. But where my research kind of sits in this at the moment is we've been doing a lot of work looking at polylactic acid. And this is something that I think is quite an intriguing material, because it's something that can be made from biomass, it can be made from plants, and it's something that can be broken down. So because there are these carbon-oxygen bonds along the structure of that polymer, these are kind of like break points in the chain where it can be chopped up back into smaller units through using enzymes or through hydrolysis with water. And so there's a lot of interest around this material. But something that we're beginning to get really interested in is what happens when you have these new materials that seem to be very sustainable and have a lot of benefits, but actually our current recycling systems are not well equipped to handle them. So for example, with polylactic acid, that is a polyester, and so is PET, which you might recognize as the soft drinks bottles. And because these are both polyesters, they actually have one part of the molecule that's quite similar. And that part of the molecule that's similar is what's typically used to separate PET from a lot of other plastics. So if you start to have these sustainable plastics, but they end up in recycling instead of in, closed loop systems or disposed of through other routes, then actually this can start to be problematic for recycling. And so we're really beginning to get quite interested in how we can future-proof recycling against new materials entering into the waste systems. And so we're looking at ways in which you can sort of chemically blend small levels of contaminants of some of these sustainable plastics into other waste streams.
Wow. And so, I mean, that's work that is ongoing right now. And we still do have, a plastic problem. There is still an issue with the fact that plastics are affecting the environment, and how we use plastics are affecting the environment. Now, I know there's always a big push by lots of companies to show how green they are. But I suppose this is a question primarily for Mark. I mean, is there a danger that businesses, companies, some of them are greenwashing as a way to attract customers? I mean, is this happening, and what are the dangers, and what can actually be done there?
Well, the answer is proper and effective labeling, so that people know the nature of the material and what the best use of it is when they're finished with it. And the best use is, as Jenni's been explaining, is to get it into recycling and getting it cleaned and getting it granulated and then going back into manufacturing other products. But our ability to do that depends on us sifting our materials, and often the best way of doing that is at the point the customer uses it. And I've really been pleased to see places like motorway services now, where people are encouraged to, from a plastic drinking vessel, for example, to pour the liquid away, to put the container in one area, the straw somewhere else, the lid somewhere else. And if the area is clean, tidy, and well controlled, we can get the consumer to do a lot of the work for us. But it needs to be a very simple and easy process. As soon as it becomes complicated, customers will throw their hands up in horror and just chuck all of the material in the same bin. So we do need to split these things up, and there is a challenge, of course, of our infrastructure. Far too much of the material that's coming back into recycling is finding its way into export and going into other countries who often have systems to deal with it, and in some cases they don't have systems to deal with it. So it's for us to deal with our own waste, but we can start by making it easy for the consumer to do the right thing and putting the right material in the right bin.
Good to know. Wonderful. Jenny, you had a point.
Yes, thank you. It's really interesting, this question about greenwashing. And I think working in an area where we're looking at polymers that can be labeled as biodegradable and compostable, I think, there's so many people who really do have good intentions, but it can be so confusing to see what is meant by different words and terminologies. And actually, a conversation that I've had with quite a few people is about how for something to be biodegradable, then, we might buy it thinking that this is a really positive change that we're making. And biodegradable can mean broken down by enzymes. It doesn't necessarily mean that it's going to be environmentally degradable. And I think there's a potential danger of things ending up in the wrong places because of how some of these words might be interpreted. And so just because something is biodegradable doesn't necessarily mean that it'll degrade in the natural environment. And actually it could be persistent and it could be littering in the natural environment. And with compostable, again, this is something that could be compostable under industrial conditions. So, high temperatures, maybe quite high humidity, or again, using enzymes. Whereas I think, when I first heard it, I would have kind of assumed, okay, compostable, that's a home compost like we'd have had in the garden outside. So I think sometimes there is, I think, that kind of clarity is really important on then polymers that are seen as being sustainable and have real potential to be very sustainable, not ending up in the wrong places once they've been used.
Jenny is right, which is that people do think that if something is biodegradable or compostable, it's automatically better. That's not necessarily the case, because I think one of the things we would agree on is that if the non-biodegradable, non-compostable product gets put into the right bin and gets recycled, that's probably more effective use of that material than the biodegradable or compostable product that ends up in the wrong place.
Yeah, and I think it's a real example of how it's not a one-size-fits-all solution, and actually there's lots of different materials that have a lot of different positives to offer, but the interplay between those different materials and how they mesh together is something that there's still a lot to do in this area, I think.
Okay, so both of you obviously have quite a lot of expertise when it comes to plastics and polymers and materials and stuff, and I'm really sorry that I'm not as clever about it as you, but I know other things like how many pistachio nuts I can fit into my mouth. I know, not relevant here, but still, I want to know that I'm on your level too. So, I mean, Jenny, are there any polymers, like any plastics, are there any polymers that we should just stop using now because they're too hard to recycle? Like, Mark might have seen them in the 80s, but right now we don't need to use them. We shouldn't use them in anything, so we should get rid of them. Are there any?
Oh, it's quite a contentious question, isn't it? Because I think, as we mentioned earlier, all plastics should inherently be recycled. And I've also heard some people say, is a material really evil? Or is it the way in which we handle that material? And if it ends up in the wrong place after it's been used, then actually that's often where the damage comes from. And I think that something that is kind of maybe key here is that it's not just necessarily that material in terms of its disposal at end of life, but actually there's so many things for us to think across the lifespan of that material. So for example, plastic bags, I think, there's been a lot of people who'd be going, okay, cotton bags, that's a more sustainable version to use, but actually it takes 500 times more energy to produce a cotton bag than it does to produce a plastic bag. And so, we can buy things with great intentions, but that means for every once we use a plastic bag, we would have to use that cotton bag 500 times for the CO2 emissions to not be worse, or for that to be equal. If we can reuse a plastic bag 15, 20 times, actually, that maybe starts to become really quite competitive. And in terms of cotton, there's a lot of water that goes into making that. So it's not necessarily just a question of that material, but it's how we interact with it. And it's kind of the bigger perspective of that across its lifespan, that I think is really important.
I think this question now goes to you, Mark. With what Jenni's sort of just said about there's no such thing as an evil material, like for me, I am quite I try and use non-plastic products whenever I can, like whenever possible. But I know there are people who think that we should just cut it all off. We should just get rid of all plastic packaging altogether. I mean, what would you say to that? Because obviously this is something that you must have heard in your all-party parliamentary group.
Yes, I have. And I know that there are springing up for people who, for the best of reasons, sort of packaging-free stores where people can go and buy a variety of generally food items. Now, for people who want to make a statement, that's a great way of doing things. But for people who want to go and do a quick shop and put something in their fridge which will have a reasonable shelf life on it, that's not going to work as well. I mean, the classic is the little bit of polythene that people put on a cucumber. That keeps the cucumber fresh for so much longer. Without that, it dries out and it needs to get thrown away. And one of the things that plastic packaging can do is preserve the shelf life. So that, I mean, another great example is the plastic container that pieces of ham would come in, that with a resealable lid. The ham will remain moist and usable for much longer than ham that's been sliced off the bone and left on a plate uncovered. So there is a role there. I accept that some people, for ethical reasons, will want to steer clear, but the danger is that it's less convenient, there's less choice, and very significantly, from a CO2 perspective, we end up creating more food waste, and dealing with food waste is a real problem.
It's really interesting. I mean, the example you gave there about, the ham in a packaging. So I think there's so much intelligent design has gone into some of these materials, actually. So if we think about the film across the top of the ham that stops oxygen from coming in and stops it from going off, then that is actually often 7 layers of different polymers, or 5 or 7 layers. But usually it's more than just one type of plastic that's in there. And as chemists, I think it's really quite an interesting situation, because these materials have been developed because they do a really high level of function. But then on the other hand, that complexity of the structure does also make them quite difficult to recycle. And so I think as material scientists, then there's a real interest there for, can we maintain some of those properties while reducing some of the complexity of the systems? And I think this is something that could be a really, really interesting area for trying to make these films more widely recycled, because in terms of mechanical recycling, the complexity of that film makes that a real challenge at the moment.
So, I mean, on that front, for some reason, we've all been talking about milk and ham packaging and rolls. So now I'm really hungry. Now, in that respect, the Co-op, they recently launched their soft plastic recovery scheme. I think we sort of spoke around that, and that shows it can be done. They're saying in store you can recycle your food packaging, your plastic bags as well. So obviously that can be done, and that's being done by, one company, one brand. Could it or should it be taken up by government?
Well, films have always been the hardest part of plastic to recycle, partly because the proportion of a contaminant on a thin layer of film in comparison to perhaps a molded container or pot is always higher. For every kilo of material, you've got much more contaminants in there to get rid of. The other issue is that recycling targets have often been set by weight. And of course, there's much more weight in the containers than there is in the film. You need to get a whole lot of film together to build up any particular weight. But the film is the next area that we need to look at. Try and keep the material as clean as possible. And of course, many of the films have been passed through a microwave, which causes the material to be sort of burnt onto the film. So separating the materials out is very difficult. But with recycling, what the government has done and the recycling industry has gone for the low-hanging fruit, the easy to recycle materials. Films are much more difficult, but hats off to the co-op for the step they've taken. And yes, of course, others will need to follow that lead.
I know that, people have been talking a lot about e-waste recently, sort of talking about how we can recycle e-waste in the future, because that's a very big thing and people are starting to take it incredibly seriously. Now, do you think that people will always be taking plastic recycling as seriously, or is there a fear that it will fall to the wayside? I'm going to start with Mark and then move to Jenni. Mark?
No, I think people do want to do the right thing. People want to know that if they separate out their materials in the home, they're going to go into a waste stream. I mean, one of the complaints I often get from my constituents is that they've gone to all this trouble to separate out their waste in their home, and then they learn that it was all stuck into a container and sent to another country, and they'll say, well, why did we bother in the first place? So we do need to demonstrate that the materials are being available for recycling, and they are making their way into other products. I was once involved in a project which involved the recycling of plastic vending cups, and the plastic vending cups were converted into rulers and pencils and other materials that were used in schools, and it was printed onto the product the number of vending cups that had gone into the use of that particular product, so people could see a direct link between the positive behavior of getting the vending cups into the right place, cleaned, into a recycling stream, and see them transformed into something else. And I know that there are one or two producers of plastic bottles now on their labeling, telling people that the bottle has been made out of 100% recycled material, so that in the choice of perhaps a bottled water, somebody may buy a bottle that is identified as being 100% recycled, and another one that may have no such claim. It enables consumers to make choices, and overwhelmingly I think people do want to do the right thing. We've just got to make it easy and simple for them to do so.
Yeah, I would echo that. And I think that with recycling being exported, from my understanding, we're sort of beginning to come to a transition period where there have been one or two countries that have stopped accepting plastic waste from the UK, and others which are likely to follow suit. And so I think this is a real opportunity here for us to start recycling more and more material within the United Kingdom. And I think that there's a really strong drive. I mean, I've had so many more conversations over the last few years. I worked in sustainable plastics for quite a while, and since Blue Planet was aired, then actually I've had so many more conversations, which has been fantastic. It's so exciting to see people being so engaged in this now. And that's been a few years now, and the momentum hasn't dropped off. If anything, I think it's given the time for this is a really complicated situation, and because it is so complicated, it needs really interdisciplinary solutions. And so actually there's been so many conversations happening between industry and academics and policymakers and charities, and trying to join up these different thoughts and these different individual areas of research to see how this can actually start to build up into a big picture approach. I think compared to the e-waste, one thing that is quite different and is quite interesting between the two of them is that e-waste is potentially seen as being more valuable, especially in terms of metals recovery. And I think plastic has traditionally been seen as something that is quite inexpensive and quite disposable, but actually this is such a huge resource. I mean, when we think about the scale of materials that exist and are still being produced, it's 260 million tons per year globally. Like, that is such a huge amount of material. And so actually, like, if this is to be handled well, and if we can have high quality recyclate coming through these different systems, this could actually be quite a source of opportunity, both economically and also in terms of new innovation and new infrastructure.
See, this is really interesting because, Jenni, overall with your work looking at sustainability when it comes to plastics, like, you can create something that's incredibly sustainable, incredibly good. But Mark, looking at it from like a economics, like a business standpoint, what will a plastic have to be What kind of properties will it have to have? How good would it have to be in order for a business to to make their switch from, let's say they're using PET, to move to, I really hope that's a real plastic, and move to, say, Jenni's new, more sustainable plastic?
The material's got to do the job. And if it fails to perform, then the consumer simply won't buy the product in that particular packaging. And that's the demand. And of course, the other bit is consumers want to buy the product at the best available price, which puts pressure on the packaging manufacturer, pressure on the food producer to do the best job at the least possible price, but whilst it performs. And that's, the message is that consumers will pass on through the purchasing trend.
How can we get everyone to work together for a more sustainable future? Because both of you come to this with very different perspectives.
As an MP, a bit of that is government taking a lead through its legislation, and there are 3 consultations going through Parliament right now, which should lead to that. And that's the extended producer responsibility, where manufacturers are accepting more responsibility for their products once the consumer's finished with it. We've got the deposit return scheme aiming to increase the proportion of bottles, particularly, that find their way back into the recycle stream. And then we've got this very key one, in my view, which is consistency of domestic collections, so that the bins will be the same across the country, which means that then the messaging can go on pack. Some people say, why isn't the what to do with the product once it's been used clearer on the bottle or the container? And that's because different local authorities are doing things differently. When that becomes consistent, we can then get that messaging.
Wonderful. And so, Jenni, how about you? How do you think we can all work together for a far more sustainable future?
Well, I would echo what Mark says about consistency being important. And I think that is, in terms of consistency of people knowing what to do, it can be very confusing if, while we weren't working from home, if, your workplace had different things that could be recycled versus at home, then it does become a little bit more complicated. But I think also in terms of consistency of materials, so the purer these streams can be for recycling, then that actually probably makes recycling processes easier. But I think from my research perspective, it's helpful if we start to see how all of these things marry together, because as a researcher, you can be working on something that you're like, okay, this is made from biomass and it's something that can be degraded under certain conditions, that can be chemically recycled. There's not infrastructure to mechanically recycle it yet, but potentially that could happen. So you can be thinking that you're doing all of these things, but then if this is to be given to a manufacturer who needs it for a different purpose and needs to blend it with other polymers and additives that then affect the way in which that material is used and where it should end up in its end of life, then actually by solving one situation, you might end up creating other challenges, such as if certain things do end up in recycling when the current infrastructure can't handle them. And so I think there's a real need for interdisciplinary solutions to some of these issues that involve people across that whole supply chain, and both manufacturers and consumers, so that there are these sort of holistic approaches that mean that these materials can be dealt with in the best way possible.
Wonderful. And to round it all off, if anyone listening should go away with one key message, what would you say it is? What is your one key message for listeners at home?
Well, to look at the packaging that they're receiving into their home and make sure it ends up in the right place. Because if it ends up in the right place, it'll continue in use. It'll be exactly what I spoke about, but it'll be a resource rather than something that's going to be wasted. So get it in the right location.
Appreciate the power that's in your hands. I mean, we've heard from Mark that actually a lot of these changes that are being influenced are coming from consumer behavior. There's so much good intention and so many people trying to do well that, whether that's in your hands by what recycling bin you put something in, or as Mark says, checking the packaging, but also, the empowerment to act, to drive change.
But Mark, Jenni, thank you so much. And now it's time to hear some news, brought to you by our reporters from the Royal Society of Chemistry.
Hi, I'm Lizzie from the Royal Society of Chemistry, and today I'm talking to David Santillo, Senior Scientist with the Greenpeace Research Laboratories based at the University of Exeter. So David, can you briefly summarise for me what your role is at Greenpeace?
Yes, I'm one of the senior scientists here within the Greenpeace Research Laboratories, which is based here at the University of Exeter for the last 30 years. And our role is a combination of analytical support through our environmental forensics laboratories and also scientific advice to Greenpeace offices around the world on a whole range of scientific issues, from plastics to climate change, forest protection, through to hazardous chemicals.
Wow, so it's a whole range of topics really that you cover, right?
Yes, and we've got a range of people here, all with different academic backgrounds. Everyone has come from a research background into Greenpeace as an organisation, and our role and our mission, if you like, is to make sure that Greenpeace is an organisation that is based in science, driven by science, and also that any science that's done within Greenpeace is of the highest quality.
So I know you're doing some work at the moment on exported plastics and the problems that come from that. Can you tell us a little bit more about that?
One of the big problems, of course, with ongoing plastic use, and especially single-use plastics, is that we don't have the capacity to recycle and handle that waste, even in some of the richest European countries. So the reality is a lot of it is still exported, ostensibly on the basis it's going to be recycled elsewhere. The reality is very often quite different. Waste piles up, it can be disposed of just generally into the environment. And what we're investigating at the moment are situations where that waste ends up getting burnt. And that releases toxins of its own, toxic substances of its own from the plastic, and also generates new toxic substances during that burning process. So one of the things that we are highlighting through our labs is the contamination that comes from that kind of irresponsible exporting and disposal of waste with open burning. Wow.
And so do we know why the waste is getting burned instead of recycled properly?
In most cases, it's simply because there is no practical solution for recycling single-use plastics. We're often sold this idea that as long as we collect and put our plastics in a recycling bin, that it's going to be reused and recycled. But the reality is that the cost of doing that, the practicalities mean that a lot of that plastic never gets recycled. It's end of life, and it either goes for incineration or landfilling in the UK or other parts of Europe, or it ends up contaminating other countries where the infrastructure is even poorer still. And that's why some of this stuff is just being burnt by the roadsides or in dump sites.
What do you see as the solution to this problem then? I know it's a big question.
Well, we have to tackle the problem at source. We can't continue to generate the quantities of plastic waste that we're generating. And of course, this is not just a UK problem. It's a worldwide problem. And the fact that plastics are building up as environmental contaminants, the fact that there isn't that waste infrastructure to deal with them, should tell us that the problem is at source. It's with producing too much, and especially producing single-use plastics. The concept that something as durable as plastic could be single-use or disposable really should be bizarre in the human psyche. So we've got to get to that point where we start looking at reducing hugely the amount of plastic we use, not using it for single-use throwaway products, and looking upstream as far as we can to see that this is in fact all part of the same problem of our reliance on fossil fuels. I mean, the links between climate change and plastics go right back to the first point at which plastics are produced and their journey down through the supply chain.
Great, I completely agree, which means I guess that it's responsibility on all of us as individuals to reduce our consumption, but also on corporations, governments to do that as well.
Yes, a lot is said always, and rightly so, about personal responsibility for reducing the amount of plastic we use and for recycling. But I think it would be unfair to put all of the burden on consumers, because people generally want to do the right thing, but they're ending up being sold packaging that's not recyclable, having to deal with local authorities that can't accept or recycle materials. There's very little information on what happens to it. So I think the burden is also on manufacturers, it's on retailers, and it's on government. And it's not acceptable simply to put that as a burden onto the consumer and say we can all do better. Yes, of course we can, but we can only do that if the system is set up to enable people to make the right choices. And that's why one of the things that we're doing with alongside the research that we're doing here, looking not just at export and burning of plastics, but also at bioplastics and biodegradable plastics as perhaps false solutions to this problem if they're also not handled properly. Also looking at plastics as contaminants in the environment, work we're doing here and collaboratively. We're also taking that information to those discussions at policy level to try to bring that information, that evidence to the decision makers to say, you cannot solve this problem by recycling. You cannot recycle your way out of the plastics crisis, even if that was technologically feasible.
So I think that takes us on to the next question I was going to ask you, which is about microplastics. So my understanding is that a lot of plastics that we think of as degradable might in fact degrade down into microplastics, as well as obviously a lot of the plastics that aren't degradable at all that get thrown away degrade into microplastics. So what can you tell me about what you found about the impacts of microplastics and also where they come from?
Well, microplastics, as we know from all of the research that's been done, and as we found also in our work, they're found everywhere. Every environmental compartment that people have looked, be it on land, at sea, in the air, you find microplastics. So they are a global pollutant at this point. And there are now concerns, of course, that they could be carrying other contaminants, chemical contaminants, maybe microbiological contaminants as well. So it's a huge problem. It's one that you cannot recall. You can't bring the microplastics back out of the environment. So again, what we've got to do is look at stopping the problem at source. And it's larger pieces of plastic, more often than not, that are contributing to those microplastics. Also, the use of plastics in textiles, those kinds of things. And unless we get that under control, then we're not going to solve that problem of fragmentation and environmental pollution. And simply to say this plastic is biodegradable, so therefore it's okay, that's a dangerous assumption to make as well, because biodegradable can mean a whole range of different things. You can measure it simply by not looking at plastics breaking down, but just breaking up into smaller and smaller pieces. Sometimes that can be enough to pass the test for degradability. And of course, biodegradability under ideal conditions is one thing. When you have the right bacteria, the right fungi, the right temperature. When you hit the marine environment, cold, salty water, biodegradability can become something of a myth. So we have to be much smarter about the way in which we're interpreting and the way in which we're using materials.
And at Greenpeace, have you been measuring the amounts of microplastics in the environment? Is that something you do?
Yes, over the years, we've done many studies looking at microplastics in river systems, in the marine environments, even at the ends of the earth. We've looked at waters from Antarctica and from the Arctic. And of course, sadly, you find microplastics wherever you look. And a whole range of different sizes and types of polymer that are present in these areas. And what we've also done through the collaborative projects that we run with others here at the University of Exeter, with other research institutes, we've also contributed to a whole range of different projects looking at microplastics, for example, in turtles, in whales and dolphins and seals, in fish, and including in sharks. That's all work that we've helped to make possible through our labs here, but it has added to that overall level of knowledge about just how far these microplastics spread throughout ecosystems. And ultimately, that's the basis of then understanding what the impacts are once you know where they are and how widespread.
Do you have evidence of specific impacts on, for example, wildlife or even human health, or are we not at that stage yet?
I would say that the evidence for impacts on wildlife on human health is growing. Human health is probably the most difficult area to research, and it's not an area that we're directly involved with. But obviously, dealing with human exposure is a very sensitive area, and there are limited ways in which you can investigate that. But there are now, there's much growing evidence on impacts on wildlife, from the physical presence of those microplastics to the chemistry of those microplastics as well. That's not research. The effects, impacts work is not research that we're directly involved in. But obviously, the information that we've been gathering and others on the distribution of the microplastics is the first step at understanding what types of species are at threat. And that could be from entanglement and choking on larger pieces of plastic, right the way down to the presence of those microplastics in the gut, in the tissues, and the impacts that they may be having.
All right, I've got one more question for you. This might be a tricky one, but obviously at the moment, the public perception of plastic is that overall it's very harmful. I'm aware that in some, it's also very beneficial to society. In your opinion, would you like to see a world where we don't use plastic anymore, or does it have a role to play in a sustainable future?
I would certainly like to see a world where single-use plastics was something from the past. I mean, single-use plastics is a misnomer, and we shouldn't be relying on generating something made out of such a durable material for single uses. I think there's also a need to phase out harmful plastics, plastics that break up into microplastics if they get into the environment, plastics with harmful additives. And if we do need to continue to use plastics in certain circumstances, we should be looking at this as a closed loop. We should be slowing and closing the loop by which plastics are manufactured, reused and recycled. Because just like any other durable material, if you can truly recycle a plastic, there's no need for it to become waste. So, rather than looking at this as being a linear process of fossil fuels to plastic to use to waste disposal, we should only be looking at plastics if we can contain them within a circular loop and also reduce the overall consumption that we make of those. Beyond that, I think that we're so far away from that position at the moment that we've just got to look at plastics as a holistic problem, right from the cradle to grave, if you like, and address all of those different aspects of unsustainability. But as a first step, if we can really drive down this concept of single-use plastics and make that become something in history, that I think would be a huge step forward.
That sounds like a great first step. Thanks so much, David.
Join us next week where we'll be talking about compostable plastic. We'll be joined by Leslie Green and Dr. Helen Hales, two people involved in University College London's big composting experiment. Trust me, I know it sounds quite strange, but it's actually really interesting, so check it out. It was produced by Hiran Joshi and Elizabeth Ratcliffe and presented by me, Dr. Alex Lethbridge. If you want to learn a bit more about the RSC and plastics, you can visit rsc.li/plastics. See you next time.